All right, today we're going to be talking about testing and front-end development. What does testing look like? Specifically today, we're going to be learning about Cypress, which is an end-to-end testing library. We will be talking about all the different other types of testing. Up to this point, we have interacted with only unit tests. But now that we're starting to work with the development, it's important that we start interacting with tests that are more dynamic and more involved into what the user interface should be doing and how our application should be behaving. All right, so let's talk about the importance of testing. Why do we think testing is important?
Make sure your code works.
Yeah, make sure your code's supposed to do what it's supposed to do, right? So far, we've had a lot of algorithmic problems up to this point, and kind of seen we've put an emphasis around unit tests to try to save us time. But imagine if we didn't have those unit tests, right? If we didn't have those unit tests that didn't account for all these different edge cases, how would you go about identifying said edge cases? The problem with being able to, and I wouldn't necessarily call it a problem, but I guess the thing that we have to consider is that there will always be human error, right? So you can't necessarily just trust a developer to be able to identify all of the edge cases and to be able to account for different instances that maybe to them it just never populated in their head. So it's important that we actually build a test suite, that we have some sort of structure that says, hey, this is the scenario that we are accounting for, and this is what the application should do. Now, in doing so, we're actually going to save ourselves a lot of time. And let's continue into what is testing. So we just covered testing. Hey, we wanted to do what we wanted to do. And let's go into the types of tests. So we have three different types of tests. Unit test, which is essentially something like PyTest and Jest, right? It's making sure that functions or even sometimes components are doing what they're supposed to do. Now, the difference between unit and integration tests is integration tests may contact a separate API, right? Or they may at least try to fake the contact with a separate API. We have worked with a front end and a backend server before when we were working with HTML, JavaScript, and CSS and a Flash server, but we never created a test where upon pressing a button on the HTML, the user interface, a request would go out to the server and that the server would be able to respond with the correct information. Now, we don't necessarily care about the server in this case. A integration test is saying my user interface is successful in sending this request and interacting with a different part of the application, and they're successful in handling the response. All right. So unit, only one platform is being utilized. So only React is being utilized for unit tests. Integration tests is saying, hey, I am able to send a request, receive a response, and I'm able to handle that response properly for the user interface. That's our integration test. Now, our end-to-end test, well, end-to-end tests move more into this is my entire application. This is what I want the user to look to the user experience to look like. And these are the different tests that we have for it. Perfect example for that, being able to log in. Well, that's an end-to-end test, right? We would have a test that essentially opens up our React project on a separate browser, or maybe doesn't even open it up. It just runs it in the background as a background service. It then emulates being a user, clicks on different buttons, types in specific input into input fields. And then after it types in the input, it actually presses the submit button. And then it makes sure that after I'm being successfully signed in, it throws me into my homepage or my profile page or wherever it is that I want to be interacted. That would be an end-to-end test, right? We are mimicking a user going through specific phases of our website and making sure that they can make it from point A to point B with both proper and improper input. All right. Now, there goes into a little bit of pricing here. So unit tests are always going to be the cheapest. The reason why they're the cheapest is because they're only interacting with one portion of the platform. Integration tests, they become a little bit more cost effective, but they're also more efficient as far as letting us know, hey, this is actually being able to handle a response. And we could see kind of the full stack loop on each side of the application. An example of an integration test for a backend server would be being able to receive a request and formulate a response. So now, once we start working with integration tests, we're starting to talk about performance. We're starting to talk about actually running things on servers. Whereas unit test is more read this script, check that it does what it's supposed to do. And if it does, give me a green light. Integration test is, hey, actually run this, make sure that there's a request being sent and that we can handle the response. Now, end-to-end tests are the most expensive, but they are also extremely effective because this will actually mimic the user going through our website. And in reality, the person that we truly care about is the user being able to maneuver through our website and ensure that they are getting the correct information and having a positive experience when using our applications. So end-to-end tests are definitely going to be our most important types of tests because they are very expensive. It usually turns into a kind of like a stepping stool, right? Where we first create all of our unit tests whenever you're developing small changes. Once you're done with your unit test and you have an entire component that you're going to iterate, then we go into integration tests, or if we're working with APIs, we first create a unit test that will mock the API call. Once that works and we know everything works, we start making integration tests that will actually send this API call. And once we feel like the application is, or the phase that we are currently working on is doing what it's supposed to do, then we would finally move on into end-to-end test. So it's a whole building block step. You typically want less end-to-end test than you want unit test. So there's not really a happy ratio to it or anything like that. Just know that the majority of the tests that you'll have will be unit. You'll have a medium size of integration test, and you'll have maybe 10 to 15 end-to-end tests because those will actually drive server costs, send requests, and occupy a lot of space and expenses. All right, let's open it up for questions. I saw a hand up from Juan, but I think you put your hand down. So let me move on to Jacob. Okay, Juan is good. Go ahead, Jacob.
Uh, so essentially, can we assume that like integration tests are kind of like a bunch of unit tests put together, or like can they be that possibly? Like, are they composed of different unit tests? Like, if you're doing like integration testing to see if like one of your components is properly grabbing data from an API, like would that holistically be considered like an integration test, but it's made up of unit tests? Does that make sense? Like, um, just like I don't know if there's like a if they kind of like build on each other.
Got it. Yeah, so they're that's a good question. They do not build on each other. They actually may even test sometimes the same behavior. So here we go into a server, and here we have a client, right? So unit tests are specific to a client. So even if we have something like, let's say we have the fetch Pokemon function, right, that we've been working with this whole time, and we have the Poke API. Well, when we write this application, or we actually see the application sends a request, the request gets processed and sends back a response, right? Oh, wow, that was horrible. There you go. All right. So that's the behavior of our application. Now, when we go into testing this, what we would do is we would write some sort of jest, or if some other testing framework. Jest is very common with JavaScript. And instead of sending this request in that unit test, what we would tell Jest is say, hey, I want you to fake sending this request. And here is the response I want you to work with. So now this unit test would pretend to send a request, but it would never touch the server. And then it would return a response that we provide. We say, hey, this is what the response should look like. So this would be a unit test, right? It never gets sent. It's only touching my client-side application. So that puts us at unit test. Now, an integration test, rather than faking the information, it would actually send the request, await for a response, and ensure that it returns the correct value. So an integration test would send the request and return a response. So that's the integration test. Now, when we're talking about a end-to-end test, one end-to-end test would be something as follows. So upon user clicking on submit button, an image of the user inputs Pokemon renders centered on screen. Now, an end-to-end test would, one, fill out the user input. It would then click on the submit button. Oh, that is not what I meant to click on. Let's go ahead here. All right, it would then click on the submit button. A request would get sent over to the server. The server would generate a response. All right, so here it would wait for the response. And then our end-to-end test would grab the image and ensure that that image matches the parameters from the response. And then it would return successful. All right, so that's the difference between all of them. A unit test will only interact with the front end. An integration test will make sure that the front and back end server or multiple areas of our application are able to communicate with one another. And an end-to-end test is from user behavior, making sure that everything renders, checking that the actual behavior is accomplished, and then returning a positive for that test. Did that answer your question, Jacob?
Yeah, that was a correct breakdown. Thank you.
Awesome. All right. And I think I saw a hand up, but I might have lost it. So let's go ahead and push forward. I don't see anything on Yankee questions or here on the chat. All right, great. So now, what to write tests for? We don't necessarily want to test every single thing inside of our application, right? There is such a thing as over-testing. So how do I decide what it is that I want to write tests for or what isn't? I think when it comes down to anything that is user behavior oriented, then we want to write a test for. So here we have a couple of examples. All right, go ahead and open it up. We have functional logic. Well, this is very important to the application and the user, right? Because if our functional logic is broken and the user goes into using our application and all of a sudden they start getting wrong information coming back, well, the user is going to have a bad time, right? If you need to pizza or else you're going to have a bad time, right? That's kind of what we're going for here, making sure that the user is having a good time the whole time. All right. Then we have API endpoints. Again, if we're sending requests to our server, the user's trying to post a picture for their profile and they're clicking on submit, but that request isn't going to the proper server endpoint and we're not able to actually process that image. Well, maybe we have some logic in the front end of where it automatically populates their image. And now the user is seeing, oh, my image was uploaded, but then they refresh the page or somebody else goes to their profile and there's no image there. That's because it was never saved in our background server, right? So our API endpoint is broken. All right, user interfaces. So anything that has to do with end-to-end tests, making sure that the user is able to actually complete the behavior of our application. Let's say we have a workout app, right? And in this workout app, the user should be able to select a workout and put in how many sets and how many reps they're putting in there. And then at the end of it, they're supposed to get a message saying, hey, this, good job. You did your workout. Well, maybe as they're putting in their workout sets, instead of it registering properly, we have a weird glitch where they're trying to go, hey, I want to register my next set, but it's not moving to the next set, and it keeps asking for them to provide some sort of input in some input field, but that input field has already been filled out. Well, that's a problem with our logic that is affecting our user interface. All right. Then we have edge cases. Something that I have encountered and that we will all encounter in the near future, is that the way we think an application should work, or the way we think is common sense for an application floor, or for an application flow, is not common sense to the common user, right? And that's why we do such a thing as studies where you have study groups that come in and actually utilize the application and they give feedback. You need to account for the average user. And unfortunately, that brings in a lot of edge cases because people make mistakes, and we need to account for a lot of improper input. I'm not going to say all of it because that's impossible, right? But we do need to account for a considerable amount of improper input, which is our edge cases. And then regression testing. So rerun test after making changes to ensure existing functionality remains intact. Now, this one kind of gets us into our, well, how does, if I write a function, or if I receive a task to write a function, or maybe write a component, and all I'm doing is I'm creating a form for a component. Well, creating the form takes me about maybe an hour, right, to make it look nice. Then I have to go into designing the form. So now we're talking to different departments like design, and seeing what color the input field should be and what color the button should be to get the user's attention. So that maybe takes like another hour or two. And then on top of that, we have to now add functionality. So that takes another 2 hours. So now I'm at 5 hours just to be able to complete this form, right? And now that I've completed the form, well, I have to write tests for it to make sure that it does what it's supposed to do. I start with unit tests. There goes an hour. I move on to integration tests. This goes another. And then I move on to end-to-end tests. So now a task that could have taken me 5 hours is taking me almost 6 or 7, right? I am increasing the amount of time that it takes me to write a test. So why even write a test in the first place? If I could just be more efficient by once I get the improper input, or I get the mistake, the glitch, I can go and fix it without having to write a ton of tests. Well, this is called regression testing. And what it allows us to do is to grow our application while being in a comfortable state that we didn't break everything else in our application. All right. I'm sure we all experienced this maybe during assessment 1 when we were working with OOP. You're making your OOP classes, everything's working great. And now we're working with inheritance. You go into the inheritance portion and you realize, oh, well, I have to move some things around. But I think I know how to move it around so that it won't break my program. You move things from point A to point B. Well, now you're passing test 15, but test 14 and 13 and a couple of tests prior to are now breaking, right? And they're telling you, hey, you're failing this test now because it's not doing what it's supposed to do. Well, that's a way of ensuring for us, hey, I need to make sure that whatever changes I make to this code or I make to my project will not break the process that other people have made before me, right? Otherwise, you'll end up in this infinite loop of just consistently going back and refactoring a ton of different components. And that's how testing saves us time. Yes, it takes a little bit of extra time to make the test, but it gives us that nice, comfortable environment where we can ensure that when we change or update our application, we're not breaking it and everything is still working correctly. All right, Juan?
Just to be sure I understand correctly, for the regression testing, you're talking about pre-writing these tests with the expected input and outputs so that you can build the code based off of the testing. So basically test-driven development, right? Or am I misunderstanding that?
So the regression test is something different. What I'm talking about is just having test overall so that you can actually develop your functionality. What you're referencing to is test-driven development, and that would be the correct order. You would write your test, then develop your application to make sure it meets the test, and then make sure that the test passes. All right, awesome. Any other questions? Oh, and ChatGPT keeps saying to edit the test. Yes, that is that is not a good thing. All right. Okay, so that kind of dives a little bit into our pros and cons of testing. So, pros, we have bug detection. We're quickly able to know I broke something. Then we have quality assurance, right? We want to ensure that all of our projects are up to a certain standard. Well, how do you enforce a standard when it comes to free thinkers and engineers that are able to create things however they want? Well, what we do is we provide a minimum standard, and that minimum standard is then enforced by testing. Then we have maintainability, something that I just broke into now. If my project needs to grow, I need to change from one server to another. Maybe I changed something in my API endpoint, or my server is now living under a different host. Well, I should be able to change 1 or 2 lines of code and run my test suite to find out if there's anything else in my code that needs to change to ensure that we can maintain our project as it continues to grow. And then we have collaboration. Well, we know that programming is a team effort, right? As we're writing tests, and maybe I'm picking up the project, maybe I finished a project and I pass it off to Roger, and Roger needs to know, well, before I start continuing working on this application and start doing my part, how do I know that this guy did what he was supposed to do? All right. Well, you could just run the test suite and take a look at the test to see the behavior that my tests are testing for and to account for anything that maybe I didn't account for. All right. So that's a very important part about testing as well. Other developers will look at your test as almost like a form of documentation, right? Because your test should quite literally describe exactly what your function or component or page is doing and why it's doing it. All right, so now the cons for testing. It's time consuming. We have overhead, which is additional code for testing adds complexity to the project, which I don't necessarily agree with this. I think that's a good thing, right? If a test is failing and you need to add some code, then just add the code. And then we have incomplete coverage, right? It's challenging to cover all edge cases, and tests may not catch all issues. So later on, as we go into our IT careers, we're going to learn a lot about the Q&A, the quality assurance department, right? Essentially, the way it works is we get a task, we complete the task, and then we pass it up for review. That then goes to quality and assurance to make sure that it actually works properly. And we passed all the tests that we were given, or maybe even the tests that we designed, and we made things as easily as possible or as flowable as possible in our opinion, so that a user can't make a mistake. I 100% guarantee that quality assurance will always find something inside of the code and let you know that it is not working the way it's supposed to be working. So when that happens, you just have to create a test for whatever edge case it is that they identified, make sure that you account for it, and then send it back for a review. All right, so it's just a constant review cycle to make sure that broken code doesn't actually make it into the deployed site. So incomplete coverage, testing might not be able to test for everything because tests need to know what they're testing for. And if we ourselves can't think about everything, then we can't write tests for everything. All right. I've been talking for quite a while. Let me go ahead and open it up for questions for everything that I've covered up to this point. Does anyone have any questions over anything that I've said so far?
Who gives like the junior developer the initial end-to-end test?
Awesome. That's a great question. I don't necessarily know. It comes from different places depending on what it is that you're working on. And it's not uncommon for you to not get test cases, right? What's going to be more common is you'll receive a user story. And what that user story looks like is almost something almost something like this, where it's going to say, hey, upon a user doing so and so functionality should happen, and this is the end state, right? So it should give you the start, the func, and then the end state of the application. right? So you'll get a ticket or a Trello card that has something like this. And then from there, we'll have all the different people attached to the tag that says, hey, you guys need to work together to complete this tasks. And what you'll do then is take a look at the user story and from there analyze, oh, this is something I'm going to need to test for. I need to make sure that I test for the API requests. I need to make sure that I test the images rendering with the proper CSS. I need to make sure that the image populates at the right time and that it won't populate without an actual image source inside of it. It's more on you than anything to be able to create these tests. Once you submit that to your senior developer or whoever's reviewing your code, the first thing they're going to look at is one, documentation, two, your tests, and you're likely going to receive some considerable feedback on things that you did or did not test before they even take a look at the code. Does that answer your question?
Yeah, it does. Thank you.
Of course. All right. So now, what is test-driven development? So test-driven development is a development approach where you write tests before writing the code, right? And this is called just red light, green light, red. Yeah, there used to be a yellow at some point, but now it's just red light and green light, right? Essentially, you write the test, you make sure that the test is able to identify the function that you're looking for and that it fails. And once it's failing, then you go about writing your code to ensure that it passes. That's all test-driven development is. We start out with test, and then we write some code, which is what we've been doing in this program since day one. So we are all pretty familiarized with test-driven development. All right. So now popular end-to-end frameworks for React, we have Cypress and Puppeteer. They are both frameworks that essentially mimic a user traveling through your site. And you just create tests where you're saying, hey, I want you to pretend that you are a user, that you are typing things into this input field, and that you then submit the form. And then I want you to check that something is populated on the screen. Then we have tests for Django. So Django has its own test suite. The reason why this is here is because we'll be diving into Django here shortly. And then we have our Django REST framework API test cases, which is just designed specifically for API requests and responses. All right, that is going to conclude part one of our lecture of why testing is important. Does anyone have any questions over part one of our lecture? Okay, fantastic. Doesn't look like anyone has any questions. Let me go ahead and pause our recording here. All right, everyone. Now that we've gotten a little bit familiarized with what is testing and we've been practicing unit tests, today's going to be the first time we evolve into our end-to-end testing framework of Cypress. Now, this part's going to be pretty important because Cypress will be running our test suite for our React assessment. We don't necessarily need to know how it's going to be installed since that part will not be evaluated in the assessment, but you do need to know how it works. So with that said, let's go ahead and start with how to install Cypress into our Vite project. I'm going to go into npm create Vite here. Oh, excuse me. I see a question on the Yankee Questions channel that I might have missed. This might not be answerable question since it is directly related to the assessment, but will the testing...
All good. You're about to answer. You just answered it for that we're using this for the assessment.
There you go. Perfect. All right. So let's go into... Oh, Gary, go ahead.
Real quick, can you send the link over
The
to
link
the
Cypress?
Yes, please.
Got it. Yes, sir. I'm just going to put it here in the Yankee Questions channel. All right. So we go into npm create Vite. Notice I put a period afterwards, so it's not going to ask me how to name my project. We're going to make this in JavaScript, and here's my project. Next, I can run npm install. And finally, I can run npm run, oh, not that, run dev. All right, and dev opens up. Here is our Vite and React project on the upper right-hand side. All right, great. Now let's move on into installing. this Cypress and ensuring that Cypress works within our project. So first, we're going to go and run npm install Cypress --save -dev. So I'm going to save my Cypress as a development dependency. So here we can go into package.json. We can take a look at our dependencies. And when we execute this command, we'll see that Cypress is being installed. Almost being installed. All right, let's give it a couple of seconds here.
Yeah, it's taking.
Yes. There you go. All right, Cypress has been installed. And it didn't go into dependencies, it went into dev dependencies. Here we can now see Cypress has been added into our package.json. All right. So now we have Cypress installed into our project here. And the next command that we need to run is npx Cypress open. So now it's telling me, hey, it looks like this is your first time using Cypress, and it does this whole thing to opening up Cypress and starting the tools. Secure coding is enabled for a restorable state. Enable secure coding by implementing NSA, okay, and returning yes. Sure, why not? Oh, nope, it's not asking me for input. All right. Here it is. All right, so now when I ran that npx open, this opened up, which is just our Cypress test suite. And let me give it a second here to answer some questions. I see we have a hand up from Quan.
Yeah, the differences between the dependencies and the dev dependencies, that's the dev dependencies are only for developers, as in like anybody who actually is trying to download your code and the full application will have to also install those dependencies. And then shipping the item will be just the regular dependencies. Is that right?
I think that's correct. Yes, the way that that's broken down, but I may have to look into that and get back to you with a more specific answer.
Okay.
Awesome.
Thank you.
Of course. All right. Well, now we're inside of Cypress, right? We ran npx open. This opened up Cypress. And when it opens up Cypress for us for the first time, the thing we're going to click on is going to be end-to-end testing. Now it's going to tell me, hey, this is not configured. So it's going to ask me, hey, do you want these configuration files? All of these are checked. I don't really want to mess with any of this. I'm going to run with the default behavior and click on continue. And then it's going to ask me, hey, do you want to run this on Google Chrome or do you want to run this on Electron? Now for Mac users, Cypress is going to be pretty simple. You can just click Chrome. For all of our WSL users, Cypress might throw a problem if you try to utilize your own browser's Chrome. So instead, I'm just going to go ahead and utilize Electron for all of us so that we could see how Electron looks. There is no real difference between Electron and Chrome. Electron is just running a dumbed down version of Chrome, right? It doesn't have the same capabilities that Chrome does, but it's still running Chromium in the background, which is just a version of Chrome. And then I could click on Start End-to-End Testing. Chromium opens up. It tells me, hey, you're good. Here is your test suite. And then it goes into specs, but currently I don't have anything. I don't have any files or spec files to actually run any test. All right, let's take a look at our project now and see what it looks like. Well, once I went into the Chromium browser or into Cypress, and I clicked OK for all of the default files that I wanted to take a look at, you'll notice that I now have a cypress.config.js. All right. The cypress.config.js is utilized by Cypress to find where our tests are going to be located, and how we want to execute our test. So this is going to be where we run any configurations for Cypress. All right. So Cypress is running pretty well now. Here we can see that we have our end-to-end test, and we have a couple of different arguments here that we are going to be changing here shortly. So now we do want to execute end-to-end tests. We have defined config from Cypress, but instead of setup node event, which is the default value that comes in, we're going to go ahead and pass in some arguments here, such as base URL. Well, the base URL that I want you to take a look at is going to be HTTP, not HTTPS, because we're not on Transfer Protocol secure, at localhost port 5173. So that's going to be the base URL that I always want you to check. Now, there's usually something called support files. And in this case, we don't have any, so we're just going to leave this as false. Actually, there you go. So there's our end-to-end testing that we want to make sure that it finds and runs. Now, we also want to specify a viewport height and width for our file. In this case, the height is going to be 768 pixels, and that does default to pixels. And our viewport width will be 1024. All right. Awesome. And then finally, it's going to ask, do we want to actually take a video of things? In this case, we definitely don't. Just going to run it for false and saying, hey, I don't want any sort of videos to be taken. All right, so this is how we add the configuration for end-to-end test. We're going to see this in action once we actually run a test suite. We just have to do a couple of things to our package.json before we go into creating a test. So let's dive into that next. And let me actually share this file here with everybody so that everybody has it available inside of Yankee questions. All of this is also step-by-step in our curriculum, so you could follow it alongside as well. All right, so let's go into adding scripts to package.json. Now, in package.json, we have these scripts, which are essentially just commands that we can execute in the terminal with npm. Right, so here is the one running Cypress, and here if I run npm run dev, well, that would occupy our server, right? But notice that dev is just the command in line 7. So I'm going to add a couple of commands into our package.json. I'm going to add cyopen, which cyopen will stand for Cypress open. It's going to open up Cypress for us. And then I'm going to add cyrun. And what cyrun is going to do is it's going to run Cypress utilizing npx, and it's going to run all of our test files. So we'll actually run the test for our test files there. All right, so let's take a look at what that does. I'm gonna Control-C. All right, we detected that Electron tab running Cypress test closed unexpectedly. We have failed current specs. Okay, great. So there you go. There is no more Electron browser. All right. I can now run npm run cy open. Oh, I didn't spell that correctly. And that opens up Electron for me instead of me having to go through the entire process. All right. It tells me, hey, end-to-end tests have been configured. It tells me, hey, there's a warning we cannot connect to the base URL. So let me make sure that my other, okay, let me run that, run dev. So that should be able to connect to the base URL. So now if I run try again, it runs it. So let's highlight that important little piece of information there. Keep in mind, I have 2 separate terminals, each of which are running 2 separate servers. One is hosting Cypress, and the other is hosting Vite. Our test suite will not work properly if Vite development server is not running. All right, I'll say that again. So our test suite is not going to work properly unless your Vite development server is actively running. All right, and I see a question there. Go ahead, Owen.
Yeah, can you go back a few steps? I lost track of where we were. I have these scripts uploaded, but after that, all those steps I fell behind on.
So you're saying you have all of these commands written, but how did I get everything to open? All right.
Yes.
So I'm gonna go ahead and kill both servers here. You'll see that Electron isn't open. In one server, I'm going to run npm run cy open. And that is going to open the Cypress terminal, right? Or open Cypress overall. So Cypress is now running. It occupies a port inside of my local machine, and it opens up a server. That server then forces this window to open, which allows me to take a look at my end-to-end test. Now here, I'm getting a warning telling me, hey, we can't connect to the base URL. Well, that's happening because my other terminal is not running my development server. So I can say npm run dev to run my development server. And then I can tell Cypress to try to connect again. Now that it works, I can open up Electron and utilize my end-to-end testing. All right, awesome. So we've made quite a bit of progress here. We were able to have our end-to-end test open up, and you'll notice that up here in Cypress, I now have a Cypress directory, which has fixtures and support. And here we could see our end-to-end for support, but we don't have any supporting files, so we don't necessarily care about this portion. All right, great. Well, now how do I actually add a test? Right? It's great that I know how to configure and install, but where should my test go? What should my project structure look like? And how do I make it work? Well, here inside of this Cypress directory, we're going to make a new directory named end-to-end. Now we're naming it end-to-end or E2E, and that matches our key here in our define config, right? It needs to make sure that it's named E2E. And inside of that E2E, we could write any amount of files. So we could say my test.cy.js. And we could even make it JSX if we want to, right? But JS will do for now. All right. So there is our first test suite. Remember in Jest, we used to have something like mytest.test.js. Well, in Cypress, we just add cy in between those two periods. That way Cypress can actually identify it. Well, Cypress is now able to identify this file, but we need to actually write a test inside of it so that it can actually be executed. Well, let's write a test that will make sure that Vite plus React shows up on the screen. It almost follows the same exact convention as Jest when it comes to writing a test. We want to start off with a describe block. This describe block typically wants to describe which file it is that we're running a test on. So here we're going to write app.jsx. This will then run a function. And in here is where we describe what it should do. So it visits base URL and checks for an h1 tag with Vite plus React. All right. So that's what my test does. It visits the base URL and checks for an h1 tag with Vite plus React. Let me actually make sure that's an h1 tag. Okay, good. It is. All right. And I see a question from James. I think let's go ahead and address that question. Go ahead, James.
I think I might have gotten a little lost too. In your Cypress directory, I think the directions were saying that the E2E should already be in there and it's not for me, and I'm guessing maybe I did a step wrong. I just wanted to make sure that I didn't have to make the E2E directory.
Awesome. Great question. Yes, we actually created this directory here.
Okay.
Yeah. So Cypress.
So you created E2E and then also created that file and then copied everything over.
Exactly.
Got it. Sorry for.
No problem. All right. So now we have it visiting the base URL. So let's do that portion first. We can call CY, which notice CY isn't necessarily imported from anywhere. We don't know where CY is coming from, or at least my test case doesn't know where CY is coming from, and that's okay. It's just VS Code doesn't understand what CY is referencing to, but we know we're working with Cypress. And CY has a function named visit. Well, we're going to put slash here. Remember, our base URL is localhost 5173. So we need it to always visit localhost 5173. That's what this visit slash does. From there, we're going to tell Cypress, which is our user, to get an H1 element. All right, so here it's going to grab an H1 element. And I also want it to check that it contains, so it should contain the text of Vite plus React. All right, so now let's watch our test suite here. So here's our node modules. Let's take a look. All right, so now it tells me, hey, we do have a test. Let me get rid of this part here. In Cypress end-to-end test, we have my test.cy. I'm going to click on that. And you can see that it tells me, hey, I passed, right? It gives me a green light telling me that it passed. Now, the really cool thing about Cypress, let me actually zoom in here so we can see that a little better. The really cool thing about Cypress is that it allows you to click through the function itself, right? So we can see it step by step. So first we tell it, hey, I want you to visit this, I want you to visit this URL, right? And here's the DOM snapshot. It tells me this is what the DOM looked like. All right, great. After that, so once it renders, I want you to wait until an H1 tag renders on the screen. We only have one H1 tag, so we don't need to worry about there being multiple values. So Git grabs the one independent H1 tag, and that's how we could see, all right, well, here's the H1, right? We have it pinned, it's being highlighted. Finally, we have an assertion. We're saying inside of this H1 should contain the text of Vite plus React. And sure enough, it grabs the inner HTML or the inner text of this H1 tag, and it checks that there is the text of Vite plus React. Now, what triggered this assertion? The should keyword is what triggers the assertion, right? We could simply do something like this as well. I believe we can assign it to variables. We could let something like H1 equal to, and then we could say, hey, H1 should have the tag. And now if we rerun all of our tests, so here it visits, here it grabs the H1 tag, and here it runs the assertion, ensuring that the H1 element actually contains Vite plus React inside of it. All right, now let's take a look at a different functionality. What if I wanted to run just an independent file, right? How could I do that? Instead of opening up Chromium and doing all of these different things, maybe I wanted to work and where as soon as I run cy run, it's just going to run one test. Well, remember in package.json, we added two separate commands. We added open, and we added one where we can specify a specific file. So I can say, hey, I want you to run. So npm run, cy run, and then I can specify the file. And let me check what that does. Okay, so options dash s dash spec and then argument. Okay, perfect. So we run dash dash spec. And then we specify which file it is that I want to run. So I want to run Cypress at end to end at my test. And when I run that, it doesn't open up Chromium at all. It actually runs everything as a background service. So even though it's not showing me the Chromium application or it's not showing me the portal redirecting me, it does in fact still open a browser. It's just that browser is not visible to me. So here we can see it. So it opens a browser that is not visible to me as a developer. From there, it visits the base URL. So here we can see the test passing. It doesn't show me step by step, but it does tell me what version of Cypress is running. It's running on Electron, headless, meaning I'm not able to see it. The node version is V20. Only one spec file was run. Here is the location of said spec file, and it was successful. It gives me a, hey, test, there was one, that one test was passing, no video was taken. It took less than a second to run my entire test file, and that's the spec file that we ran. All right, awesome. Does anyone have any questions regarding Cypress and how to run Cypress?
Yeah, could you go back to the Cypress config file and show the file path in there? I was not able to get that.
Of course. So if we go back to the Cypress config file, we specified that what we want to look for is end to end. So that's what tells Cypress. Inside of Cypress, there should be a directory named end to end. And for all end-to-end tests, my base URL will be localhost 5173. We won't be using any supporting files. Here's the viewport height and width that we are going to demonstrate within Electron. And we are not going to be taking a video of the test suite. All right, and I see the thumbs up going. James?
What was the terminal command to kick off the spec, the specific spec run?
Yes, for the specific spec run, if we go to package.json, we have this cy run npx cypress run dash dash spec. So we do npm run cy run, which is this command here on the left-hand side. After that, we have to pass the dash dash spec flag. And then we could specify the path to the file. So the relative path from where I'm currently at in my terminal to the testing file.
Okay. Do you have to know that path, or is there an easy way to just like copy paste? So was that what Owen was just asking about?
For the path, if you don't want to actually know it from the terminal, and I gotta say I don't feel comfortable showing this, I would rather everybody utilize your terminal skills and get familiar with the terminal to be able to find paths and maneuver around in your directory. But you could also right-click files, and here you can see that it gives you the option to copy path or copy relative path. But please try to avoid using clicking around in VS Code as much as possible.
Okay, cool. Thank you.
Of course. All right. Any other questions? Let's hear it, Gary.
When you ran the test, it said a headless, right? If I
Correct.
recall. Assuming because it specifies that, is there a way to see it? Do you know what I mean? Like with head and not headless, or
I'm sure there is. I'm sure we could have it run with head. Let me see. I think that ran it headless again. I would have to take a look at the documentation real quick.
yeah, no problem.
Yeah, there's got to be a way to do it where you could just specify the head. It's probably just a flag. I don't know it off the top of my head, but I know for a fact that you could do it.
Yeah, I was wondering if it would like give us a visual or something.
Yeah, I mean what it would do if it wasn't head is it would do the same thing as CY open, where it would essentially just show us this portion.
Oh, I see. So headless would just be in the terminal versus head would just be here.
Right. So this is head.
Gotcha.
Headless would be terminal.
Gotcha. Thank you.
Jacob?
Yeah, just make sure I got it correct. You made the E2E directory yourself, right? Within the Cypress directory.
That's correct.
Okay, cool. I was just not messed up right now.
No problem at all. All right. No other questions. I don't see anything Yankee questions. Okay, fantastic. With that said, I'm going to go ahead and stop the recording.